Hi there, how are you guys? Well, in this topic, we'll create a Java program. At the same time, of course, the topic would be something like this. Okay, the topic is about what? HCI to Java programming. Okay, and we'll apply the OOP or OOP. Stands for Object what? Oriented Programming. So this will be our topic for today. And at the same time, of course, we all know that HCI is part of prototyping in mock and in creating mock-up design. So HCI stands for what? Human computer interaction. So this is a very what you call this quick discussion about the HCI and how to apply the HCI using the Java programming. So what are the requirements for the HCI? Number one is of course basic, well, of course, perception in any programming language. This is very important. You can write the code. Okay, you can write the code. And for this session, we will use the Java. So next is of course no good perception on how to write the algorithm. What else? We have the algorithm. Of course, we can use also the conceptual mapping. Conceptual mapping. So these are the basic requirements. And 2.2 will of course now aside from your algorithm conceptual mapping, well of course you can write also the pseudo codes. Okay. For what? For HCI text prototyping. We are not here to discuss about, of course, we will not discuss about this mock-up design, but we are here only to discuss how to create a basic and rough prototyping by means of programming. We don't have any visible illustrations for or whatever for the program. So we need only to integrate the human-computer interaction, okay, as part of its usability and how to apply it in real world. And of course, apply the OOP. This is also to revisit what is OOP, that's object-oriented programming. So remember about OOP, well, of course, when we are talking about OOP, we're talking about class. Class are the composition of objects. Okay. And objects describes what variety of properties. Okay. So this is our task for today. Now let's move on. And of course, I'm using the online Java program. So we're gonna start first with our prototyping. So the first part of this prototyping, well, of course, we can create a prototype. For example, what is our task for the prototyping? We'll of course create a program that will what you call this display the following what you call this objects or is of course objects. So we have the objects right here, 1.1. So we can say that of course we need to display the axis watt power. And of course, the behavior is, of course, this is a numeric. Therefore, we'll be using the data literals of int. It involves what? It involves numbers. Okay, this is very simple. Number two, well, of course, we'll gonna what you call this the power box in, of course, the axis type. So we'll be using the string right here, and of course, we describe this as what of any axis type. If this is a meta type of axis, then we can use the reptile. We can use what you call this the bird. We can use the aqua. So we let's use the reptile. This involves what? String. This involves string. So, well, of course, we assume that you know what is a string. This is composition of numbers and letters. If you combine 2 or 3 characters, it become a string that is encapsulated by your double quotation. Okay, so this is what we're doing right now. So we don't have any what you call this. I just want to repeat. We don't have any rough sketches or drawing for this, but we are using the text-based type of markup design, applying the other part of your HCI. Okay, so let's start. So we have here the online what you call this editor, and you can use also any type of editor, but I'm using this because this is lighter, and of course, at the same time, well, this is already in the net now. So we'll start with the program. So if you want to start with the program, okay, what is our task right now? The task right now is what? To create the algorithm. So this is part of the algorithm. Create a program that will display the following objects: axis, power, numeric, okay, and of course, axis type string. And at the same time, will of course, part of the program is to, what are the part of our program? Will of course create a class name, and then provide the field members of the class, field members. So what are the field members of the class? These are your objects. These are, of course, we can say the methods. So method is your what? Is your function. So we have the two types of methods. We have, of course, a defined methods, and we have, of course, a built-in methods. Okay. So we have also the constructor. So the constructor is part of the class. This is a class. Okay. It builds the class for your data. Okay. So we have there the two algorithm, create a class name, provide the field members of the class, objects, methods, functions, constructors. This is a class. And at the same time, of course, what else? Call the objects in the main program. Okay, so there you have it. So we have here the three basic instructions or algorithms for our program. This is now the mechanics. All right. So we're gonna create a program right here, and of course the name of the class is, let's say, well, of course I will be using the public class. Okay, this is the modifier. Public class, my, of course, my axi game. I mean axi list. All right, that's it. We start with the open parentheses, the statement with the open brace. Okay. And of course, we don't have any particular package to declaration at the top. All right. If you want to check my previous instruction, well, you can visit my previous flag. Now, we will create the field members of the class. Field, this is the field members of the class. We need to say, this class has the list of the objects. It's on the program. Now, if you were able to study before the data structure, but of course, just like to creating the struct for the C++. Okay, field members of a class. So we have here the private modifier. The purpose of private modifier because this is belong to a class. So we have here private int, and then we put here, of course, power axi. So this is the power of axi. So let us check our program right here. We can involve the power of axi. So axi power or mobility is, let's say, well, let's say axi mobility. We put it that way so that it will be more intuitive. Axi mobility. So we have here the axi mobility. That's power of axi mobility is, let's say, 90. And then we have also the private string. That's capital letter. It's totally different from the C++. And let's check our algorithm right here, because this is part of your design. Design is integrated to human-computer interaction. So this is where we're gonna involve the string. Okay, string, and of course the name of the axi. Let's say the axi name is, let's say, reptile. Okay. Now this is now the field members of the class. This is the class name, and we're creating behavior of the class wherein we can use this as part of our micro library later on in the main program. Now the next part is, of course, we have to declare our class right here. Of course, class myAxi. So we need to provide, there are two types of class. In OOP, we have the default class and we have the parameterized class. So this, in this case, we'll be using the parameterized class. Let's say public myAxi list. All right. So we're gonna declare here, of course, that will pattern also with this field member, so that every time that we have the setters and getters, it will match to our request. So how to start with this? Okay, so we have to declare it first int. We can use A1, stands for axi, and of course, string for, let's say, A2. Okay, A2 stands for axi. A1 stands for axi mobility. Okay, so this is integer because this will match to our parameter. Okay, now the purpose of this is this is a property of my axi list. Okay, so that's the purpose of that. So we're gonna use this axi and then mobility. Now, if you cannot understand this, please go back to my tutorial in my Java tutorial, in my channel. Okay, mobility, and then we have to put it this way. So this is A1. All right. Therefore, we are assigning the parameter to this axi mobility. We have two parameters. So we have the numbers and the string. All right. So we have this point, and then at the same time, we match the axi. This is a string to A2. Now we have here, of course, the parameterized axi. Now let's create now what was the field members of the class. What is that? Okay, the methods. So we will use the two methods right here. We have the setters and we have the getters. So what's the purpose of the setters? Setters is to change the value of the variables, and getters is to display the value of the variable. That's the purpose of that. Now we will have to go right here and of course create another, what you call this, method. So this is your method, void. It starts with a void. And of course, what's the name of the setter? You can use any name for the setter. Let's say set data. Okay. So if you want to set the data, well, of course, you need the parameter because that's how you return the value to the main program. So there's no problem with the getters. Getters will just display and fetch the information coming from the data that was already modified. So let us just start with that. So how to do that? We will again create another variable. Let's change this, or we can override that. But again, I want to use another variable still to match the, what you call this, the private variables at the top. These are your instance variable because that's private. Correct me if I'm wrong. So that's A3. Okay. And then we're gonna copy this thing. Okay. To set the data. This is part of the return value to be parameterized. This is part of the data to be what? To be modified. Can you get the point? So this is now your A2, and this is your A3. All right. So we're gonna go right here and of course create now our getters. The getters is to display the data. It's very simple. So if you want to display the data, I'll just copy it all. Okay, we'll just type the program right here and then void, and then put there get data. So you can use any name of that of your method. So we don't need to provide now the parameter because we need only to display the data. So system out print line. Okay, these are the, what you call this, the record, the AXI record. Okay, record. So we can put it here plus, then we need to infuse now what? Of course, we have here this point AXI and then mobility. Be sure that the spelling is correct. And then we have here plus, and then plus. Don't forget that this property, this point AXI. Okay. Now we're gonna move to the next part. So we have now these members. So this my AXI list own the following: the objects of AXI mobility, the AXI. At the same time, it owns also what you call this, the parameterized of my AXI list. Remember, this is a constructor. Okay. And of course, this we have the two methods that will. What is a method, by the way? That is just like a representation of a tool. Wherein if you want to cut a wire, you need a method to cut a wire. What is that function? Well, you need a cutter to cut the wire. You cannot use the the device for cutting a wire to cut a cookie. That's not a story, diba? So that's part of it. Now let's move out and of course create now the program. This is now the main program. Okay. So public static void main. Then we have here string and then args. Args stands for arguments, of course. Please go back to my channel and of course watch my other video for this explanation. So we're gonna, what you call this, create now the constructor. We'll have to create now the constructor. So our constructor is right here because we have already constructed all the ingredients for our myAxi underscore list, right? So let's say you're gonna copy this thing to be sure that this is correct and there's no wrong spelling for the program. So this is now the myAxi list. We need to provide here, of course, the object. So we need to instantiate the object right here or the variable. So the object right here is we're gonna put object one so that it will be more clear and intuitive to the end user. And then we create the constructor. Constructor is, you know, is always provided by the new reserved word. So my axi list. So this is what you call this, a default constructor. But we need to provide now the constructor right here. So I'm sorry, I'll put 90 here. I will change this later. Okay. So I'm gonna put here, of course, the mobility and at the same time the name of the axi. So the mobility is a character is an integer, so I will put there 90. At the same time, we put the double quotation because the parameters tells that, okay, in our instance variable, we have the integer and we have the string. Do you get the point? Now, if I put here, of course, the name of the axi, let's say the axi is reptile, all right? That's the reptile, okay? So I'm gonna check this and erase this. Sorry for that, okay? So I'll just, of course, put this as a blank, there will be a blank data at the top so that we can put it right here. So we have already created the constructor right here. And of course, this object is already part of the myAxi list. Meaning to say, this is just a modifier that will assign a program to object one, inheriting all, of course, the field members of the myAxi list. Can you get the point? So let's move on. And then at the same time, we're gonna call now, of course, how to display this. Now, we cannot display this unless otherwise, but of course, we use the get data. So the get data will of course be displayed by means of using the parameter also. This point axi mobility. Look at that. axis mobility, and this axis. Whatever we assign here, it will be displayed and be called in the method. So this is part of now of the program. So therefore, the point is just like you're calling the child program of the my-axis because object now, it is now a reference program for the my-axis underscore list. So what will happen right there is we need to get the data, display the data. So we put there get data, and then we don't have the parameter. All right, let's check what will happen. And then this is part of where we end the static void main, and we have here ending the program and class. All right, so this is how we do it. Now, we base our program, okay, the meat of the discussion is what is the relation of HCI to any programming technology? Because, well, of course, it is imperative that, is it really imperative that you need to create, or you need to create first the mock-up design and of course involve the HCI to write the program? The answer is yes. Because if you are doing the human-computer interaction, we need to say you are there to prepare the mock-up design for the end user. So one of the ingredients is, of course, how your program works and how it can communicate to the audience. So in this case, well, of course, we are trying also to create a program, a simple program, elementary type of program that will display the characteristics of your axis. So in this case, the interaction is very simple. You are there to what? Set the data and modify the data. From the endpoint of the user, well, of course, the endpoint of the user is to control the program. How to control the program? There's no way that you can control the program because we don't have the button here. Our case here is to display only the data and, of course, explain, of course, the the basics of human-computer interaction. Okay, so this is how you create the prototyping by means of Java using the object-oriented programming. Let us run the program and check if there are some errors. So we have the errors right here because this is a syntax error. Okay, so you better be careful about the errors. And then when we run the program, okay, let's examine if there are some errors. These are the axis record 90 reptile. Okay, that's correct because for one thing, we declared here, okay, in the program, we declared here, okay, look at that. We declared here 90 reptile. If I declare this as 10 and put here the bird, the mobility of the bird is 10. That's the example. I'm not denouncing the power of the bird. No? So this stands for your axis mobility. Okay. All right. These are the parameters that we return to the main program. And we have here the bird for the string, matching the string, right? It's very simple. So again, we have the following program right here. We have the field members, the instance variable. This is owned by my_axis underscore list. And we have the two methods, set data and get data. And we declared our object as part of the my_axis underscore list. Now, it is now pointing to my_axis underscore list. And then we create the parameter right here. So this object right now owns the following get data because it refers now to the get data program because it was already constructed and of course reference to my_axis underscore list. So when we run the program automatically, well, of course, it will display another data. Look at that. So these are the axis record 10, and of course we have the bird. Now let's say we play a bit here, of course. So one of the prototyping is to create the interactions from the program, of course, the program. We're talking about the program and we're talking about computer interaction. And one of that is, of course, preparing a prototype for the program. Okay, you see first the result before you do the actual data. Okay, now, let's say if the data entered is 10, of course, we will say cool axis. If the data is not 10, if the axis mobility is not 10, then it will display frail axis. So if we can create a condition like this and put the property and then of course axis underscore mobility, we can put it right here because this is OOP. OOP is cool and easy equals to 10. All right, let's say or, okay, no more or, so we can say system dot out dot print line cool power, okay, of axis. So this is an example for that. Otherwise, well, of course, we can put the else statement right here in system out dot print line. Okay, you need to change your axis. Now, what happened if this is put in the main program? Okay, remember this is part of a parameterized axis. So this will be validated if you enter the parameter of 10 because this is an integer. So it will say cool power of axis. When we run the program, Okay, let us check what will happen. So we have here system.print line. This is a wrong spelling at the top. Okay, this is our system.out.print line. This is a wrong spelling. So let us run the program again. So there you have it. Okay, cool power box because we validate it. Okay, using the number 10. All right. If you change this to 100, okay. If you change this to 100, all right. This will display what? You need to change your axis. These are the axis record 10 bird because we are there to put 10 as the bird mobility. All right, so there you have it. Okay, so this is part of your human-computer interaction, how applying this to Java programming. Of course, no, please don't forget to subscribe and like this channel.